In today's day and age, emergency services and law enforcement are using drones to arrive at the scene first to gather critical information. This could be the location of a criminal in an active shooter situation or the coordinates of someone in need of search and rescue. To make this happen, the drone has to be able to be controlled and have a communication link to reliably give back video, picture, and command and control information. At AgileRadioCom, we make sure this communication link is present and alternate paths are available. In doing so, we make sure the drone never fails and that the flow of information is always present, giving lives the highest chance of being saved. In this demonstration today, we're going to show you one of those alternate paths of waveform switching. In this, we use two different waveforms, OFDM, which is commonly used in Wi-Fi and has a high data rate, and DSSS, which has a little less data rate, but much more robust for congested environments such as a hallway or a major city. So in this, we have our B210, which is our receiver. This is connected to an antenna located up here. And then for our transmitter, we have our antenna located here, and it is connected to the atom Pluto. So at first we're going to run this. It's going to be to show how a legacy system would operate. So as we came here, we're going to have a pop up here to show us. And then I'm going to start the transmitter. And as you can see here, the OFDM waveform is now present. It's coming in, and we have our messages being printed. So this is showing the data link up and the communication working correctly. And now we're going to have some sort of interference present. As you'll see a giant spike here. So now what this is showing is that the packets are going to stop coming in because the system isn't resilient and it can no longer keep the link up. Now we'll show you how it works with our Agile system. So we start it up once again. We start the transmitter. We see our OFDM coming in, our packets are present, and now we're going to introduce the same interference, but when this happens, it's going to switch to the DSSS waveform. And as you can see, it's switched, and we're still having packets come in. So even though with interference is present, the link does not go down. This is how we are resilient and agile in this situation. Drones are more safe, reliable, and resilient on the communication we build that they depend on. Now my colleague Raul will go over the hardware and a more detailed demonstration.
Such complex algorithms require hardware that is one, capable of performing them within a limited amount of time, two, is robust enough to be put on drones that could be flying with some of the harshest environments on the planet, three, that is lightweight and compact to be placed on any standard sized drones that could come in multiple forms. Here is an exploded view of what our device would look like. And now let's consider a scenario where our device is mounted to a drone that is on an intelligence, surveillance, and reconnaissance mission for the military. The drone's camera is connected to our device using standard interface, which then transmits the data to our base station, which could be either stationary or dynamic. Now to demonstrate that, we have a Raspberry Pi that is connected to a night vision camera. And what we're going to do is record a short video. I'm going to start it and place it right here. And now that is done recording. So it's going to transfer the data from the Pi to our FPGA, which then transmits the data using the RF front-end to our transmission antenna, which is then captured here using our RX antenna, which is then connected to this SDR right here, which is then connected to this PC where we see our packets accumulating. Now, we are designing to manufacture a product with built-in hardware level security. So the drone and its data are protected against tampering, cloning, and even eavesdropping from the chip up and not just the software. And it is future-proofed by design. It is ready to absorb new waveforms, new security standards, and new mission requirements without requiring a full-fledged hardware redesign. Now, as you can see, we have received the video on the RX side.